So we have seen some experiments. It is about the electrostatics. All the objects in the world is made up of atoms. The atom consists of protons, electrons, neutrons, and the center of atom is called a nucleus, which consists of two particles, proton and neutron. The proton is a positively charged and neutron is zero, neutral charge. Electron is a negatively charged, which is moving around the nucleus, and it is a lighter particle in the atom. The lightest particle in the atom is electron. So what happens if we disturb electron by rubbing, giving some friction with another object? For example, you take we have taken a balloon and then we are rubbing it with a woolen cloth. So what happens? The outermost orbit, it has a lots of orbits. The electrons are having revolving around the orbit. So when it is the outermost one, the electrons which is moving, which is revolving outermost, which will be having a least force of attraction by the nucleus, because the nucleus is positively charged, electron is negatively charged, so the attraction will be weaker for the outermost electrons. So these electrons can be removed by disturbing, like rubbing, giving some friction. So this electron can transfer from one object to another object. That's what we have seen in the experiment. When you rub the rubber, that is a balloon, with a woolen cloth, the electrons are being transferred. Note the point, only the electrons can be transferred, not the nucleus. Here we are not talking anything about the nucleus. We completely discuss about the electrons. The electrons can move from one object to another object because it is lighter, and also the outermost electrons, which does not have any attraction or a very less force of attraction from the nucleus. Okay, so what happens if you rub the rubber ball against the woolen cloth? Both objects get charged. How both objects gets charged? For example, here is a balloon and here is the woolen cloth. When you rub against each other, the electrons from the balloon jump into the woolen cloth, and here is the balloon. Okay, so this wool receives electron. So as it receives electron, here the majority of the charges will be negatively charged because it receives electron from the balloon. So this one loses electron, so the majority will be positively charged. There will be negative charge, but the majority will be positive because the electrons are being transferred. What was the charge before you rub balloon and wool? Here is a wool and cloth. Positive, negative, equal number of positive negatives will be there, and in the balloon equal number of positive negatives are there. So before it was a neutrally charged. That means neutrally charged means they have a charge but they cancel each other. Positive and negative charges are being cancelled out, so it is called neutrally charged. As you are rubbing each other, the electrons, they go and accumulate here. So as the electrons from this object moves this object, here more electrons, here more positive charges will be there. So the electrons, more negative charges. The object which has more negative charges, more electron will become negative. The object which loses more electron will be positive. So what happens? The both objects now it is positively charged, so they attract. Like charges, unlike charges, we know that like charges they attract, unlike charges repel. So that's what happened there. The balloon attracts the paper, balloon attracts the paper, right? Then balloon attracts the water stream. These are the small experiment we did. And then using electrostatics, we have several applications, like a spray paint. You can paint using electrostatic application, electrostatic concept. Here is the nozzle. Inside the bottle, here is a bottle, it has a paint inside, and at the nozzle they connect positive or negatively charged using a battery. Suppose the nozzle is connected, positively charged battery is connected to the nozzle. So when the paint is coming out, when you spray, the paint comes out through the nozzle, so it is connected to the positively charged, so the paint particles are being, it becomes positively charged. So these positive charges, like charges, it is called like charges. Like charges repel. So as it repel, it can cover a bigger area to paint any object easily. If it is not repelling, what happens? You can see a stream, like a narrow stream. So it will take, now you have a bigger surface, so it can paint only this area, but here you can cover the bigger area, you can paint it. So that's what we are using the spray paint. So what's the another benefit? The object where you want to paint will be connected oppositively charged, right? That, for example, the paint particle, the paint here is changed to positively charged, so the plate where you want to spray becomes negatively charged. You have to connect the negative terminal of the battery here, so it becomes negatively charged, so it attracts, all the positively charges are being attracted. So well, the wastage of paint is minimized, and you can paint the plate or any object easily at a shorter time, as it is covering a bigger area, right? And even if the paint particles they move up, or the other side can be attracted, the plate, the back side of the plate can attract the paint molecules which is flying away from this, then it will be attracted. So the minimum wastages are there. So we are using the spray paint. The same concept here, car paint, any scooter, anything, any vehicle, you can paint using the electrostatics. Another is electrostatic precipitator. That means in the factory where you want to send the waste gases which is going through the chimney, at the top of the chimney they have the plates. One is positive charged plate, or either positive or negatively charged plate. Now for example, here you can see precipitator. Here we have a mesh, so this is positively charged. Okay, what type of charge here? Positive. So it must be negatively charged. This mesh, it is like a mesh, like a small holes will be there, and it is negatively charged. So all the dust particles which is passing through the mesh turns into negatively charged. So now the dust particles are negatively charged, which is being attracted by the positively charged plate here, which is connected at the top. So waste gases without smoke particles. So actually the smoke particles are being charged, right? So the smokes are being attracted by the plate because the plate is positively charged. The smoke becomes negatively charged before it enters to the mesh. Here at this point it's neutrally charged, no charge it has. When it touches the plate here, the mesh, it becomes negatively charged because we have connected a negative terminal of the battery, and here positive terminal of the battery. The plates are connected positively charged. So what happens? The smoke particles are attracted, and the waste gas will go outside. And then agricultural water sprayer, same like the spray paint. Many of the country they are using this method to minimize the usage of water. Here in this case we have to spray the water, we are not pouring the water, so you can save water using electrostatic spray. Here electrostatic fingerprint, the same method. We are using positive and negative charge. Wherever you see the fingerprint, if the fingerprint they turn into positive charge and negative charge, there will be a powder, negatively charged powder. They will spray it onto the positively charged fingerprint, so the fingerprint will attract the negatively charged powder, wherever the print is stamped, pressed, it will attract. So you can see the finger print. This is electrostatic application. Then another application, we are using it in the photocopy machine, lightning arrestor. This lightning arrestor also an application of electrostatics. Here the cloud has a positive and negatively charged. So then if it is a negative at the bottom, by induction, here on the building, positive charges are accumulated, collected, a building up of charges. As it builds up lots of charge, there will be a great lightning which can damage the building. So if you connect a rod, a conducting rod like a copper rod, and the copper rod is connected to the ground, so what happens, these charges are accumulated on the terrace, on the top, will flow to the ground. If it is positive charge, will be neutralized by getting electrons from the ground. So the electrons will flow through the copper rod to the top and neutralize the positive charge, and finally there won't be any charge and there won't be any lightning. So this is called lightning arrestor. In case if there is electrons on the top, if it is electron on the top negatively charged is accumulated, these electrons can flow to the ground, because only the electron can flow, no positive charges will not flow. If on the top positive charge, electron will go to neutralize. If the top terrace on the top, if it is accumulated, negative charges are accumulated, collected, these electrons will go to the ground through the rod. That is the difference here. It depends on what type of cloud is closer to the building. That's all. Next, that's all. Okay, these are all the applications of electrostatic, and lots of other applications you can explore. And thank you very much watching my video.